In this video, we're going to learn how to solve a quadratic equation with tables. Now, we're going to solve each equation using tables, and we're going to give each answer to at most 2 decimal places. So this would mean that we're going to be plugging in a bunch of values for x until eventually we get to our solution. But to make this process go by a little bit faster, I'm going to use my calculator. So what we're going to want to do first is move all terms to one side so we can find these zeros of the equation instead. So we'll add 2x, give me 5x squared, plus 32x, and then minus 2 plus 12 equals 0. So what I'm going to do is, now that I have everything on one side of my equation, I'm going to go to y equals and plug this expression into y1. So 5x squared plus 32x plus 12. And now I'm going to make a table, which is right here above the graph key. So second graph, and it makes a table for us. Now as I scroll through, I get 1, 0 at -6. So one of my solutions is x is equal to -6. But as I scroll down, I see that it goes from -15 to +12 between -1 and 0. But I can't see what the solution is. So what I'm going to do now is, if I need to be more accurate, I'll set my table to be something a little bit different. Otherwise, you just have to keep plugging in values between -1 and 0 until eventually you get close enough or you reach 0. So second window brings me to this. But I want to start here. It's between -1 and 0. So I'm going to start my table at -1. And then right here is the delta table. It pretty much says what we're going to count by. I'm going to be a little more accurate, so I'm going to put by 0.1. Now when I go back to my table by hitting second graph, it's going to start at -1 and it's going to count by 0.1s. And I'll see here when it gets to -0.4, I get another 0. So my two solutions are going to be -6 and -0.4. Now let's try another example. So I see here I have 4x squared minus 14x plus 7 is equal to 4 minus x. So I want to move everything to one side of my equation. So now I have 4x squared plus x, so minus 13x. Then minus 4 gives me plus 3 equals 0. And I'm going to reset my table back to 0 and count by 1. Then I'll go back to y equals, and I'll have 4. Clear that out first. 4x squared minus 13x plus 3. Then when I go to my table, I'll see that I get one of my zeros at 3. So x is equal to 3. And my other 0 seems to be between 0 and 1. So I see it goes from 3 to -6. So there's probably a 0 in between there. So I'll go back to my table set. So second window, I'm going to start at 0 because it's between 0 and 1. I'm going to count by 0.1s. Go back to my table. And I'll see here that I still don't see it, but now it's between 0.2 and 0.3. So now I'll go back to my table set, and I'm going to start at 0.2. But instead of counting by 0.1, I'm going to count by 0.01 to be that second decimal place more accurate. And when I do this, I see eventually I'll get 0.25. So I'll have x is equal to 3 and x is equal to 0.25. Now I'll try this with one more example, because so far these two equations could have been factored. If I would have factored this, I would have had 5x squared, two numbers that multiply to 60 but add to 32. So that'd be 30 and 2. And I could have grouped them, and they would give me 5x times x plus 6. Factor out of 2 times x plus 6. And I would have x plus 6 times 5x plus 2, giving me two solutions of -6 and -2/5, which is negative 0.4. And I could have done the same thing for this equation as well. Two numbers that multiply by 12 but add to negative 13. That would have been negative 12 and negative 1. And again, grouping them together, there's a 4x in common in my first term. I can factor that out. Be left with x minus 3. There's a negative 1. I can factor out the second group to be left with x minus 3. And that gives me x minus 3 equals 0. And 4x minus 1 is equal to 0 for a solution of 3 and 1/4. But now, with this next example, if I were to subtract 11, x squared minus 7x minus 11 equals 0. There's no way to factor this. There's no two numbers that multiply to negative 11 and give me negative 7. So now I must rely on some sort of like plugging in or estimating feature in order to finish solving this, at least with the knowledge that we know now. So to figure this out, I'm going to go by y equals, plug in x squared minus 7x minus 11. And then I'll go back to my second window to set my table to start at 0 and count by 1. Now when I put my table in, I have one answer between negative 2 and negative 1. I can't see. And another answer between 8 and 9. But I can't see what the solution would be. But I know it's between negative 2 and negative 1. So I'll go to my table set. I'll put negative 2 to start and count by 0.1. As I get more accurate, I see that it's now between negative 1.4 and negative 1.3. So back to my table. Start at negative 1.4. Count by hundredths. As I keep going down, it's negative 1.33 and negative 1.32. So now I'm getting close to it. I only need 2 decimal places, but I need to know where to round. So I need to go a little bit closer. So now I'll put negative 1.33 or 1.34 and count by thousandths, which is 0.001. Oop, I hit graph on accident. And as I keep going down, it's going to be an answer that's between negative 3.22 and 3.21. So that's closest to negative 1.32. So that'll be one of my solutions. X equals negative 1.32. And I still need to find my other solution, which I remember being between 8 and 9. So if I go back to my table set, I'll put 8 and I'll count by 0.1 to start. I'll see it's now between 8.3 and 8.4. So I'll put in 8.3 and I'll count by 0.01. And I see it's between 8.32 and 8.33. So I'll go back to my table set, put in 8.32. Count by a thousandth, which is 0.001. I hit table by accident again. Graph by accident again. And if I scroll, now I see it's between 8.321 and 8.322, which means it's closest to 8.32. That's where it would round to. And that is how you solve a quadratic equation with tables.